Finally, we ask, what can you determine if you know delta S, A, and V naught? You might think of a situation where you know delta S, some displacement, some acceleration A, and an initial velocity. And then ask yourself, what can you get? What could you get if you put delta S together with A? What could you get if you put A together with V naught? What could you get if you put delta S together with V naught? Can you make any conclusions, and what conclusions can you make? You won't be able to make a conclusion in every case, but some combination, one of the three combinations, these two, or these two, might give you something. Well, actually, no, they don't. Nothing gives you anything. The reason for that is, well, if you know a displacement and an acceleration, it doesn't allow you to conclude anything. Acceleration and initial velocity without time or final velocity or something doesn't tell you anything. And displacement with initial velocity, there are too many things that you don't know. You can't make any determination. You can't determine change in velocity. You can't determine average velocity. You can't determine final velocity or time interval. So what can we do? Well, we have the two most basic equations that we wrote down before. VF equals V naught plus A delta T. Delta S equals VF plus V naught over 2 delta T, obtained from the very first situation where we knew V naught, VF, and delta T. We want an equation where we can use these three variables, and we note that neither of these equations helps us. If we know delta S, A, and V naught, well, in this equation we know V naught and we know A, but we don't know delta T and we don't know VF. We can't do anything with this equation. Similarly, with this equation, what do we know? Well, we would know V naught here, and we would know delta S, but we don't know VF or delta T. So we're stuck. However, if we put these two equations together, and if we eliminate delta T between the equations, what are we going to get an equation for? Well, these equations involve the five basic variables, VF, V naught, A, delta T, and delta S. If we eliminate one of the variables, we'll be left with 4. And if we get the right 4, then knowing 3, we'll be able to find the fourth. If we eliminate delta T, it turns out that what we're left with is an equation in V naught, VF, A, and delta S. We know V naught, we know A, we know delta S. If we have an equation for these four things, we can solve that equation for VF. So what we're going to do is we're going to eliminate VF from these two equations, and we're going to obtain an equation for these four variables, and we could solve for delta T. Okay, so there are two different things we can do. If we eliminate VF, we can solve for delta T. If we eliminate delta T, we can solve for VF. In order to eliminate VF, it's fairly easy. We've got an expression here for VF. We just substitute this expression on the right-hand side for VF here, and VF is eliminated. To eliminate delta T, we could solve, for example, this equation for delta T, getting VF minus V naught over A, and then we plug that in for delta T here, and we would get an equation that involves these variables. We'll see next time how that works.